to do the cumulative length or the zigzag method with an existing topographic map. So you need these in order to have a goal slope within topography, because we don't want something too steep for people to walk on. And the lower the slope, the more comfortable it is. And we would want it under 5% in order to have ADA approved. And relatively, the goal of solving both the cumulative length and the zigzag method is pretty similar, but the way of solving them is relatively different. Usually for the zigzag method, we would want to find the distance, the length between each contour, contrasted to the cumulative length is between each elevation point. Cumulative length is usually more curved, while the zigzag method is sharp and goes back and forth. So let's solve the zigzag method first. To solve the zigzag method, we want to use the equation length equals dE over S. Length is so we know the length between one contour to the next, this length, going this. dE is the distance between each contour. And I know by looking at the map, each contour is 2 feet. 800, 802, 804, 806, 808, 810, 2 feet. So we know this is 2. And the S will be that goal slope. Since I want it to be ADA approved with no ramps, we'll just say I want it to be 4%. So 0.04. So to find the length, we'll use the calculator. 2 over 0.04, 50 feet. So the length of going diagonal of zigzag, each zigzag between each 2-foot contour is going to be 50 feet. Since this scale is 1 inch equals 60 feet, 0, 10, 20, 30, 40, 50. So between each contour, we're going here, from here to here. A little cheat to do this really quickly and a lot easier is to get a flashcard and measure it out and cut it to the 50 feet, which measures out. And so in the zigzag method, this is when you choose your own adventure and you go back and forth. So we can say from here to here, it's about 50. Here to here, that's 50. And maybe I want to go this way. And so on. So that is pretty much how you do the zigzag method. Now what if I want to do the cumulative length? This time we can use it on elevation points. So for example, I want to go from here to here. So how do I solve it? Relatively, we use the same exact equation. Length and we still want to find the length between here and here. And so what if, and I still want to remain 0.04%. But DE this time is not 2, because from going from here to here is not going to be 2 feet. So this time we subtract. Since this is higher, the high point, and this is the low point, we subtract 776.9 minus 767.0. So it's 9.9. Then we solve. So 9.9 divided by 0.04. So from here to here, we need to go 247.5 feet. So this is when you get a wire, a string, or whatever. I prefer a string. And with your scale bar, you measure that distance. Two hundred 247.5 feet. So this is going to be a long distance. It doesn't have to be very exact because these lines are so close to each other. So this is 240 right here. So it's about here. And with that string, it could be any curve. But as you can see, it doesn't need to be curved because it's already exceeding the length. If it is exceeding the length of the string, as you can see here, that's fine. That means the longer the length, the more flat the slope will be. But as you can see here, when I go from one point to the next, I had to curve it because the DE was bigger, had a bigger amount than going from one point to the next. So I had a curve. And if you don't have any spot elongations, like here, you can refer to contour lines and can use the same cumulative length method. And so again, the difference between the two is I feel like cumulative length is more for if you use bigger distances from one point to another, and zigzag is more for if you're going on a very steep slope and the distance between one point to another is a lot smaller.